Hey gang, so let's take a look at the measures of central tendencies. So we're going to start off with the mean. The other central tendency is the median. This is great vocabulary to use when you're writing your IA. Talking about the mean, the median, and you know the other word, that is the mode. Mean, median, and mode. Those are the central tendencies that you already know. But there are two new ones that I'm going to introduce to you today. It is called the variance and the deviation. The variance and the deviation. Now you know the mean. We have a symbol for it in statistics that we use a lot. It looks like mu, the Greek letter. It's the sum of the data divided by the number of the data points. So let's say the sum of data, and I'm just going to put over number of data points. I'm going to abbreviate that. That's the mean. You just take the average of it. The median. Now here's where I heard us talking about this the other day in class. Some of you were getting the mean and median mixed up. I will not call names, but I know who they are. Sit at the back table. Okay. The median is the data set in the middle. It's the middle number. Okay, it's the middle data. The one that's smack dab in the middle. Okay, the mode, that's the class or the data that occurs the most often. So I'm going to say the mode is the class with the greatest frequency, because that's more statistic type words. The class with the greatest frequency. The one that occurs the most. All right, and these right here are our brand new measures of central tendencies. And I'm going to give you more definitions on those when we get down here, when we get to those. I don't want to put it up here just yet. Okay. What we want to do, let me also put, I wrote a note here and I wrote the range. I didn't really write a definition, so I don't really know how I want to write that. I'm just going to say the range is the spread of the data, the maximum value and the lowest value. That's the range. It's the spread of the data and what it looks like. The one number that best represents the data is the average. That a lot of times is referred to as the mean. The one number, if I were to look at the data, the one number that best represents all this data, we're going to call that the average. So I feel like one of the best ways to talk about central tendencies is to look at examples. And so I want to take this one right here. So the table over here, the table shows the data found by asking 20 students how many different countries they have traveled to in a lifetime, including the one which they live. Find the mean, median, and mode of the number of countries visited by the group of students. So I'm going to give you just a minute. If we were in class, I would give you some time to work it. Here, I'm going to say pause your video. See if you can figure it out. Mean, median, and mode. Okay, so hopefully you paused your video. And now we're going to it. All right, so I'm going to start off with the median. So the median is the data in the middle. Now, remember, this is the frequency. So if I were to write this out, this is not X and Y. This is the frequency. People who visited one country, 4 students in the class visited one. If I were to write this out, remember this would be 1, 1, 1, 1, 4 people. 2 countries were 6 people. So I would do 1, 2, 3, 4, 5, 6, and so on. Now, I'm not going to write out all of it. I'm just going to put dot dots. I just want to remind you what this says. That's how we read that. So the median, I need to figure out what is the absolute. If I were to spread all this data out, what is in the middle? Well, remember, to figure that out, I need to do that cumulative frequency. I can't write tonight. My contacts are doing weird things. All right, so we start with 4, and then we're going to add up. Okay, and remember we had 20 students, so we should add up to 20 over here. 4 plus 6 is 10. 10 plus 3 is 13. 13 plus 4 is 17. I got to sneeze. 17 plus 2. Oh my goodness, y'all. 19 plus 1 is 20. Okay, so in the middle, the median, I would say all 20 of them divided by 2 would be the 10th spot. Where does the 10th spot occur? Well, it would occur because you'd have 10, I'm going to do it like this. You'd have 10 numbers here, and you would have 10 numbers here. That means the middle is between the 10th and the 11th number, right? That's where I want to look. Where does that occur? Well, the 10th and 11th term is here and here. So it occurs right smack in between there. Oh, sorry. So that means somewhere right in here is where it occurs. So that's between 2 and 4 countries. So if I were to list it out, think about it like this. I would now have 4, 4, 4. And the 10th and 11th spot, this would be the 10th. This would be the 11th. The middle is right here. So I'm going to have to say 2 plus 4 divided by 2 is 6 over 3, which is 2. That means the median. Oh, I just drew a blank. Oh. Sorry, y'all. Oh my gosh. Okay, let me pause that. Oh, wrong button. What? Okay, if I could read my own writing. 6. That's where I was. Okay, y'all already know where I messed up. I did the math, and I was like, wait, where did I get 3? Okay, 6 divided by 2 is 3. That means the average, or I'm sorry, the median is 3 countries. So when we did this, we were looking at these numbers over here, and we found 3. Because the 10th and 11th term, these are counting the countries, is 3. Even though we didn't even have 3 countries as our choice over here. So we're going to say 3 countries. That really threw me when I had that 3 down there. Oh my gosh. Okay, it's late. It's always late when I make my videos. Okay, which one occurred the most? Well, let's see. Now we're not looking at the cumulative frequency. Which one occurred the most? 2 right here. It occurred 6 times. So the mode is going to be 2 countries. That occurred the most often. And I bet if we were to poll people in the class, most of us have probably been, some of you may have been to Canada, but a lot of us have probably been down to Mexico. I know I've been down to Mexico, but I've also been to Canada. So I actually would do 3 countries. Yeah, I guess that would count, right? So, and let's do the mean. The mean is the average. Now here's where, hopefully you paused your video and you figured out the mean. The mean is 3.6. But I'm going to remind you how to do the mean. We need to add up all the data and divide by the number of data points. All right, so here we go. I'm going to do one country worked by 4 people, right? So 1 times 4 plus 2 times 6 plus 4 times 3 plus 5 times 4 plus 7 times 2 plus 10 times 1. And I need to figure out how many points were on there, right? We already know that we had 20 people because when I added up all the frequencies, I got 20 down here, right? That was the total. So I need to divide it by 20. Now, I'm not going to take the time in the video to plug all that in, but I am going to tell you what I got was 72 over 20. When I did that, and then when you divide 72 by 20, so 72 divided by 20, you get 3.6. Now you might be, well, how do I know what sig fig that is? Well, if I wanted to do 3 sig figs, I would need to add a 0 on the end to get it to 3 sig figs. So keep that in mind when you're working those. All right, so that's just a basic one there. Let's go to number 12. The table gives the daily high temperature in degrees Celsius in Paris, France, during the month of March. Find the mean of the temperatures rounded to the nearest 10th degree. All right, so this one is the mean. I'm not going to do all of this one on the video, but I am going to walk you through it on how to do it. So for the mean, I'm going to have to look here that the temperature of 6 occurred 2 times. So for the mean, that's going to be 6 times 2 plus 7 times 1 plus 8 times 2. So on. In statistics, a lot of times we'll do things like that because we know what we're doing mathematically. I just don't really want to write it all out. All the way down to 19 times 3. Okay. I need to take all of this and divide by the number of days we did this for it. We did this for the month of March. March has 31 days in it. If I were to add all of these up, I should get 31. Because this is representing the days that it happened, it should add up to 31. And if you want to check that, you can. I'm taking the mean, so I'm going to say is approximately, I got 12.3. I ended up with 381 on top divided by 31. All right, so I don't want to take the time to work on the video, but you can pause your video and go look at it. Take a quick look at it. All right, let me turn my page. All right, this is example 14. The crab fishermen count the number of crabs they catch in each trap in order to approximate the weight of the crabs they have caught towards their legal quota. The table shows the data for the first 135 traps. So over here we've got the first 135 traps. Estimate to 1 decimal place the mean, mode, and median of the number of crabs per trap. All right, so we are going to do, let's do the mode first. You know what, because the mode is going to be the easiest. Which one occurred the most? Well, this one right here, right? Now, this one we have to be careful because we have an interval. Remember, anytime you want to estimate something or say that what the mode is, we want to find that mid-interval, right? So on this one, estimate 1 decimal place, the mean mode. Yeah, so we're going to estimate that. So I would say from 101 to 110 is 105.5. So the crabs that had the most frequency was 105.5 crabs. Estimate the mode. Yeah, so I'm going to say 105. I almost think I would say 101 to 110 crabs is the one that occurred the most. I'm looking at my notes. I don't like what I wrote in my notes. I think I would say that. The median, the one that's in the middle. Well, in order to figure out in the middle, I need to figure out where I'm at. So we had the first 135 traps, so this adds up. I'm going to put this right here. I'm going to say this adds up to 135. This is the frequency. This is not the cumulative frequency. In order to figure out where we are, we need to figure out half of 35, right? 135. So 135 divided by 2. We need the 67.5. We need that trap, the one that happens right there. So in order to figure that out, I need to add these up. So I'm going to write here cumulative frequency. So this is 6. So here we go. We're going to do 6 plus 18, get 24. 24 plus 32, 56. I'm going to add this up. 56 plus, I don't want to make a mistake. 56 plus 48 is 104. 104 plus 26 is 130, and then plus 5. So here's our 135 traps. We took 135 and we divided it by 2 and we got 67.5. That 67.5 occurs somewhere in here, right? Because this takes me to 56. Number 67.5 is going to happen somewhere in here, meaning that the middle point is in here somewhere. Now, it's in this interval, but if I were to do the median on this one, I would want to say that point right there, 105.5. That is the crabs per trap. The median is at 105.5. it's inside there somewhere. That's my average. And that's the one that is in the middle. Now let's look at the mean. So the mean is mu. We need to add up everything in here. Well, in order to do that, I don't know 71 to 80. I know I had 6 that occurred here, but I don't know how much. So what I'm going to do is take the midpoint between 71 and 80. 71 and 80. Sorry, I didn't say that very good. So I'm going to do halfway. Here's what I'm going to do. I'm going to take 80 minus 71. I'm going to divide that in half. That's 4.5. So I'm going to take 71 and add 4.5 to it, 75.5. That's the midpoint, the mid-interval, I should say. That means that this one is going to be at 85.5, this one at 95.5, 105.5, 115.5, oh, and 125.5. Those are my mid-intervals. I don't know, like, I'm sure I had some that were less than this and some that were more, like some were closer to 80, but I don't know where, so I just take the average of this and the average of this spread, and that's what I'm going to use. Okay, so to find the mean, we're going to add up all that data. So we're going to say 75.5 occurred 6 times, plus 85.5 occurred 18 times, plus, put one more, 95.5 occurred 32 times. I'm going to put plus dot, 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 because I know the math here I'm doing. 125.5 times 5. So there's that. I need to divide this by all the fish. Well, I had 135 fish. Now, again, for the video part, I'm not going to make you guys sit through me plugging all that in. Pause the video if you want to do it, and then hit start again. I'm going to give you the answer. So I ended up getting 13,742.5 over 135, which gave me about 101.8. The average of all the fish, all 135, the average crabs per trap was 101.8. Not a bad haul, not a great haul, but it's not a bad haul. That was the average of all the crabs in the trap. The middle was 105.5, and the one that occurred the most, which makes sense that my average would be in there, was this right here. Doesn't it make sense that the average and the mode kind of go together? All right, here we go. Number 15. The following table of values is incomplete, but you know that the mean is 15. Find the value of x and give your answer as an integer. All right, we're going to test your algebra skills. Let's see how you do. Oh, I've got to get my mouse over here. Here it comes. There he is. Okay, well, here's my values. Here's the frequency. Let's do the cumulative frequency. All right, so we're going to start at 2. 2 plus 4 is 6. 6 plus x, I don't know. But I don't know that value, but I do know that if I go 6 and 6, that would give me 12. 12 and 5 would give me 17. 17 and 3 would give me 20. 20 and 2 would give me 22. So are you okay with me saying, I sort of know it's 22, but I'm really off x. I need to know what that x is right there, because that x is throwing me off. So I need to have that right there. I know that when I add them up, the average, the mean, is 15. So pause your video, see if you can figure this out. I'm going to go ahead and use my algebra skills to solve this. I know that the value of 4 occurred 2 times. And when you take the average, you simply add everything. Oh, that's a times 4. And then I would do 13 times x. I don't want to put another times there. That would be a little confusing. 14 times 6 plus 21 times 5 plus 23 times 3, 26 times 2. Now, because I had to go into 2 lines, I'm going to do this. Divided by the total. The total is 22 plus x. Okay, let's simplify this right here. Okay, so 4 times 2 is 8. 5 times 4 is 20. This is 13x. 15 times 6, or I'm sorry, not 15, 14. 14 times 6. 21 times 5. 23 times 3. And 26 times 2. Okay, so I'm just going to, again, use algebra. I'm going to add these up as best I can. So, only because I'm not sure where you are algebraically, I'm going to add 8 plus 20 plus, I can't do this because it's a different family. So I'm going to do 84 plus 105 plus 69 plus 52. So that's 338 plus 13x over 22 plus x. Okay. Whew. So I've got this algebraic expression. What I do know is that the average, the mean, is 15. So here's what I'm going to do. I am going to change the mean to 15. And I'm going to solve this. Now, there's a lot of different ways to solve this. I'm going to actually come on this other side, and I'm going to put 15 over 1. And I am going to do the butterfly method, and I'm going to cross multiply. Because I feel like that's like the easiest way to do it. 1 times all that mess is just 338 plus 13x. 15 times all of that, remember you've got to chunk it together, and it becomes 15 times 22 plus x. Man, this is just a multi-step equation. This is what my algebra kids are working on right now in class. I'm going to hippity-hoppity distributive property. 15 times 22. All right, I'm going to do 15 times 22, 330. So 330 plus 15x. I'm going to subtract 330. So that's going to give me 8 equals, I'm going to subtract 13x from both sides. Those cancel out, those cancel out. 15 minus 13 is 2x. I'm going to divide both sides by 2. X equals 4. Okay, let's go back and double check what we were trying to do there. The following is a table of values is incomplete, but you know the average, you know the mean. What's the value of x? Well, we know this x right here is actually 4. So we've had it, wanted it to an integer, and we did it. All right, moving on. Dispersion. All right, I think I'm just going to keep going. Okay, so dispersion. We're going to go back. We're going to pick up variance and deviation, which is what I talked about before. And I kind of wanted to wait on that until we got to here to finish that. So let's talk about the range. Remember I talked the range is about how far the data is spread out. So on the range, we're just going to say how far the data is spread out. How far data is spread out. Okay, that's the range. The IQR, the interquartile range, is the difference between Q3 and Q1. So we're going to say IQR equals Q3 minus Q1. It's the difference between Q3 and Q1. The variance. Now, I haven't given you this. What in the world is the variance? So the variance takes the dispersion of the data, and it talks about how does it work around the mean. So variance is talking about how does the data vary from point to point. So I'm going to say that variance measures the dispersion. Dispersion is how the data is spread out. Measures the dispersion of a, let's say, a set of data points. Set of data points around, oh, can I make it fit the mean? Ah, it's not going to fit. Okay, that's okay. Around the mean. Remember, the mean is the mu. Variance has a symbol that goes with it. It is sigma squared. That is our variance. I'm going to come over here and I'm going to put sigma squared. Now, deviation. Deviation is a measure used to describe the spread of the data within a population. They're very, very similar. The deviation is sigma. The variance is sigma squared. The deviation is just sigma. The variance is always positive. If you're going to square a number, no matter what it is, it's going to always be positive. The deviation, though, we can move to the right or to the left. But since the deviation is coming after you've squared it, because we're going to find the variance and then take the deviation, it's going to always be a positive value too. It's pretty cool how that works. So let's give you a definition here. I'm going to put, it's a measure used to describe the spread of data within a population. The spread of data within a population. We use sigma. What we also use is the square root of sigma squared. Again, because you're squaring it, it's going to always be positive. All right, I do want to give you this. This was something that I learned this year as I was studying for this. I didn't catch it last year. Oh, you know what? I want to put this up here too. Sigma equals sigma. I just want you to have that in your notes so that you can remember, because we're going to learn a lot of Greek symbols, and sometimes it's helpful to know which one you're talking about. All right, so you've got a population versus a sample population. Remember, you have the whole Denton High School versus just the freshman class. So in your calculator, when you're talking about a population, we're going to use sigma squared. When we're talking about a sample population, we will use s squared. And I'll show you on your calculator, we're going to do the square root of sigma for the deviation and the square root of s squared for the sample. Most of the time, we're going to be talking about sigma. We don't really talk about this much, but we'll get to that where we do. All right, one last thing I want to just put up here. The higher the value, the higher the deviation, the more spread out the data is. If your variance and deviation are big, the data is really spread out. Okay, so let's just write that there. The higher the value of sigma, the more spread out the data. Oh, my boys are having fun with Alexa. All right. You might even want to just highlight that or draw a line under it. There we go. Okay, so I've got two sets of data, set A and set B. And what I want to do is take a look at this data and show you what I mean by range, IQR, variance, and deviation. Okay? So let's take this data. We now know how to use our calculator on it, correct? So you know what, these are really not that hard of numbers. Well, maybe I should just do it this way. So the mean is just the average. Actually, I'm kind of lazy. I'm not really wanting to do that, so I'm going to clear it out. So I'm going to do 3, 4, 5, 13. I'm just going to put it all in. It'll be faster. 14, 18, 21, 23, 25, and 26. I'm going to do stat, calculate one variable. I didn't have a frequency list, right? So I'm just going to hit enter all the way through just so I can get this done quicker. The mean, which is x bar, is 15. The median, median is 14. The mode, well, I'll have to look. The mode is going to be 13, right? And the range is going from 3 to 26. So I'm going to do 26 minus 3. The range is 23. All right, let's do the other one. Let's do stat, edit. I'm going to go up and clear it out. Here we go. 3, 12, 13, 13, 13, 14, 15, 16, 16, 24, 26. I think I did that right. Stat, calculate one variable, make sure I don't list a frequency. The mean, x bar, is still 15. The median, oh wait, it's going to give me that, isn't it? The median is 14. The mode, which one occurred the most? 13 occurred the most again. The range is 26 minus 3, which is 23. Different data, the exact same values. So now you're like, okay, well, what did that show? That shows you the range. It's all the same. But let's look at the variance, the spread of the data. Look at this. And look at this. Which data in your eye looks more spread out? Let's take a look at what they would look like. We're going to do a box and whisker plot on each one, okay? We're going to call this one up here set A. This one down here is going to be set B. This is where I wished my computer would let me pause so that I could just do this and you wouldn't have to watch. But if you are watching it, thank you for hanging out. Feel free to fast forward through all this. Okay, so I'm going to put 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. Okay, for set A, I need to go from 3 all the way out to 26. Let's see, the mean on this one is 15. The median. I'm going to put that, you know what, I probably should, yeah, I think I'm going to do this. I think that's why I left all this over here. Let's do this. The mean on this one was 15. Q1 and Q3. We're going to need to calculate those. I should have written that down when I had it. The mean is 15. Q3. Oh, I can't give you that. Let me go back here. Okay, so on this one, this was my second set of data. I still had it in here. Q3 was 16. Q1 was 13. And the mean, remember that up at the top, was 15. The median. And then set A, I did that wrong. The median. I was looking at my data, I'm like, that's not right. So I was just looking, I did it wrong on my other one. I should have written median was 14. Okay, I did that wrong up here too. It's the median. I knew that. Okay, so stat, edit, no. Oh. Okay, let me go put these back in. 3, 4, 5, 13, 13, 14, 18, 21, 23, 25, 26. All right, stat, calculate one variable. All right. Median is 14. Q1 is 5. Q3 is, ooh, look how spread out that is. All right, let's even do the IQR. So this is going to be 16 minus 13. That will be 3. And then we'll do 23 minus 5 is 18. Okay. So again, I'm just going to graph all this. So 5 is Q1, so that's right here. That's Q1. So this comes down to here. I'm going to draw my box. And it goes all the way out to 23. Oh my goodness. And the median is at 14. And this is Q3. And then it goes to here. Whoo, look how spread out that data is. All right, down here we're going to go from, we're still going from 3 all the way up to 26. Our median is still at 14. Q3 is at 16. And this one's at 13. So, this one, do you see this spot right here? That's our data there. Gracious. So, this says that most of our data, 50% of our data was right in here. Look at this one. 25% was here, 25% was here, 25% was here, and 25% was there. This data is very spread out. Set A, I'm just going to put this down here for you. Set A is what we call more widely dispersed. Wide. Okay, y'all, I don't know if there's neither or not. I apologize if it's misspelled. Dispersed. Oh, these big words. Oh my gosh, I can't spell. Set A is more widely dispersed. All right. And that's all I'm going to put on that. I've got some things in here about sigma, but I don't want to put those on there. Okay, so that's dispersion. This is the spread of the data. We're going to use our box and whisker. That'll help us look at it and see how much it is dispersed. Well, okay, so that kind of makes sense. Let's talk about variance. What is variance? So variance is written as VAR, or most often sigma squared. It is a measure of the spread of the data around the mean, what it's doing around the average. Not the median, but the mean, around the average, what's going on. Standard deviation, sigma, is the square root of the variance. Always make sure that you square it and then take the square root. That way the deviation is always, always positive. Thus, variance and standard deviation measure the spread of the same manner, but one is the square of the other. So, set A, set B. We've got the same exact thing going on. Okay. I'm going to show you how to do this on your calculator, but I'm going to show you how to do it by hand. Because if you want to talk about standard deviation in your IA, you need to show the calculations by hand. It takes up a whole page when you do it in your IA. It gives you a nice, easy mathematical table that is super easy to work with. Okay, going from the data we had before, we already know that the average was 15, right? Wasn't that right? Wasn't that what that was? Yeah, the average X bar was 15. On both of these, the average was 15. Here's how you calculate the variance by hand. You put your data point here, 3, 4, 5, 13. I went ahead and did it twice, 14, 18, 21, 23, 25, and 26. The way you calculate it, we're going to do the variance. We're going to take 3 minus the mean. So this is going to be 3 minus the mean. 3 minus the mean is negative 12, right? Now we're going to take that and we're going to square it. So we need to square it, and we're going to get 144. Let's do it again. We're going to do 4 minus 15. That is negative 11, and we need to square it. That's going to give us 121. Then we keep going. This is 5 minus 15. Then we're going to do 13 minus 15, 13 minus 15, 14 minus 15, 18 minus 15, 21 minus 15, 23 minus 15, 25 minus 15, and 26 minus 15. As you go down, you're going to get negative 10 squared, negative 2 squared, negative 2 squared, negative 1 squared, 3 squared, 6 squared, 8 squared, 10 squared, and 11, sorry. Got a little excited there, 11 squared. All right, so let me put all these squares on here. You may already be fast forwarding the video to get past this part. I'm going pretty fast. Okay, so this is going to be 100, 4, 4, 1, 9, 36, 64, 100, and 121. Now, in order to figure out the variance, and we'll do this one next, but I'm going to show you this one. Here's the formula for finding the variance. The variance is the sum. Anytime you have that E, that stands for the sum. We're going to go from I all the way to N of what we did here. X sub I minus the mean squared. So all of these values, we're going to sum up all of these values from 1 to whatever it was. So in this case, it was 3 to 26. And we're going to divide by N. How many did we do? In this situation, we had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You can kind of think of this as this is I equals 1, I equals 2, I equals 3, all the way down to I equals 11. Okay, if that kind of helps you. Let me put dots there. You guys couldn't quite, there it is. So let's plug it in. It would be 144 plus 121 plus 100. I'm going to do plus dot 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 plus 121 all the way down to that end. I sum up all the squares, which is what this is, and divide by the number of terms, which was 11. And that gives me the variance. Now remember, when you're finding the variance, we're going to remind you that this is the variance. So that means the variance is, in this scenario, 64. The standard deviation, which is sigma, would be the square root of 64, which is 8. Now, I want to remind you how to do this on your calculator. Okay, so I give you that same data up here at the top, and I say, hey, let's find the standard deviation. And so I'm going to use, let's see if I use this one, 3, 12. Okay, I'm going to use set B right here. I think that's what I used on here. 3, 12, 13 was 3 times 1, 2. Yeah, I did. So we did this one by hand, but we don't want to always do it by hand. So here we go. So let's put our x's. 3, 12. 3 occurs 1 time. 12 occurs 1 time. How many times does 13 occur? 3 times. Keep going. 14 occurs 1 time. 15 occurs 1 time. 16 occurs 2 times. 24 occurs once. And 26 occurs once. Now, I did put down here some steps for you to help you, but I don't think that these steps right here are, I accidentally did it for a different set of data. So this is just showing you the steps to push your buttons, but this data does not match this data. Okay, so here we go. Stat, edit, 3, oh no, that's the different data. Okay, 3, 12, 13, 14. Okay, stat, calculate. Now, I don't have the I don't have the frequency there, just to make sure I did that right. Stat, calculate one variable. I need to put the frequency. So remember, you do second, and then the number 2 down here has that L2 on it, so we're going to hit that. That puts L2 there, and then we're going to calculate it. All right, so we're going to look, and we're going to see our X bar, so our mean is 15. And then we want to try and find our standard deviation. Do you see it? Our standard sigma x, our standard deviation of the sample is 5.799. If I wanted to find the variance, I would need to square it. But what I'm going to do first is change this to 3 sig figs. 5 point. This 9 would round that 9 up, and this 9 is going to round that up. So it's going to end up being 80 for my standard deviation. My variance, I would simply square it. 5.80 squared. My variance would be 33.64. Now, when I look at this, the standard deviation was 8. The standard deviation was 5. The bigger the standard deviation, the more spread out the data is. 8 is much bigger. Look at this. The variance was 64, and this one was only 33. So you can see that this data here, set A, was much more spread out than my set B. And that, I mean, variance is not difficult to work with at all. So we're just going to run through and see if we can, see if we can do some of these. So these are just some more check for understandings. Let's see. Yeah, I'm just going to go ahead and keep doing these. Okay, so in 2017 Track and Field World Championship, 13 athletes qualified for the finals in the men's javelin event. Their distance rounded to the nearest meter over here are given in the frequency distribution. Use your GDC. Oh, that's the first time we've seen that. Let's put a note here. GDC equals, do you know? Graphing display calculator. You are going to see that a lot. GDC, graphing display calculator. Use your GDC to find the standard deviation. Give your answer to 3 sig figs. Hallelujah, we do not have to do this by hand. All right, so there's not really a whole lot to show here, y'all. We're going to go here. We're going to go to Stat, Edit. Let me clear all this out. 91, 86, 85, 84, 83. How often did it occur? I don't have to do a cumulative frequency. It's just put the table in. Stat, calculate one variable. Ooh, I've already got the frequency there. There it is. So they just want the standard deviation. 1.9, 3 sig figs. Give your answer to 3 significant figures. There it is. All right, the next one. A cell phone company compiled data for 200 of its customers, analyzed texting activity by finding the average number of texts they sent each day, rounded to the nearest whole number. The frequency number table below shows their findings to 1 decimal place. Very important, to 1 decimal place. Where approximate? What is the mean? We got to do all this. We got to do the mean. We've got to do the standard deviation, the first quartile, the median, and the third quartile. I'm surprised they didn't ask for the IQR on that one. All right, pause your video. See if you can do that. I'm going to get going on this too. Here we go. I'm going to go to Stat. I'm going to go to Edit. I'm going to go up, clear, down, over, up, clear, down, over. 12, 13, 14, 15, 16, 17, 18, 19, 20, and 6, 15, 29, 41, 35, 25, 18, 19, and 12. I'm going to double check. I did that really fast. 6, 15, 29, 41, 35, 25, 18, 19, 12. Okay, I feel good. Stat, calculate one variable. My frequency list is already there. Here we go. put that right there. The mean is, I got 15.99. I need to do 3, actually no, it said to 1 decimal. So I need to do this to 1 decimal. That would be, so the 9 would round this 9, and this 9 is going to round this. So to 1 decimal, I'm going to need to put a 16 there. The standard deviation, remember I'm not doing the sample deviation, I'm doing the standard, is 2.059. So again, to 1 decimal would be 2 point, the 5 is going to round the 0, so that's going to make that 2.1. Q1 is 14.5. Oh, nice, it's already done for me. The median is 16, and Q3 is 17. You know, just for kicks, because I can. If I wanted to know the IQR, I would do 17 minus 14.5, and I would get 2.5. Could I make a box and whisker? You bet. Standard deviation is 2.1, so the data is not too terribly spread out. The variance, if I wanted to do it, would be the standard deviation squared. I could do 2.1 squared, and it would be 4.41. Lots of information I can ask you, and all you do is a simple stat edit. All right, number 18. Okay, this one's got a lot of numbers on it. The 20 clubs in a football league finish the 2018-2019 season with the following number of goals per club. Ooh, all those. Use the data to summarize the number of goals, the scores per club in terms of the standard deviation of and mu. Use the data to summarize the number of goals per club in terms of the standard deviation of mu. I guess I just forgot the period there. I guess that's what that is. Okay, well, I guess we're going to be putting this into our calculator. Oh boy, here we go. So I'm going to do stat edit. I'm going to clear all this out. And I'm going to do 89, 79, 69, 65, 63, 59, 50, 50, 49, 48, 44, 44, 44, 43, 41, 35, 33, 32, 30, 30. Stat, calculate. Okay, so I did remove my frequency. So here we go. Let me put that on there so you can still see it. So the mean, or X bar, is 49.8. My original one, I had 49.85. I think it's because I used a frequency table. My standard deviation is 15.98. 983. Or if I did it to 3 sig figs, 15 point. Ooh, you know what? I think I kind of want to, well, no, I guess I could just leave it 50. I kind of want to leave it, because that 8's going to round that to 9, round that 9 to 10 and make it 16.0. I kind of want to leave it 15.98 just for now while I'm showing you guys this, because I kind of want it to be a decimal like that. So here's what I know. I know the standard deviation. I'm going to write it here. The standard deviation is, I'm going to use 15.9 for this, okay? 15.9. Here's the way the standard deviation works. Now we haven't done this yet, so this will be the first time we've done this. We're going to draw a line. And we've talked about the bell curve a couple of times. I'm going to go ahead and draw a bell curve and show you how the standard deviation works. The median is right here, and this is going to be our average. The average, where everything just about fell. And my average fell at 49.8. Now, my spread might not be a beautiful curve like this, but for this picture, I'm going to draw it and say it's a beautiful curve. When you move to the left 1 deviation, or I could move to the left 2 deviations, or I could move to the right 1 deviation, or 2 deviations, or 3 deviations. Okay? a lot of times we do put negatives on here. I should have put that right there. Let me move that over. And these show how far away you are from the mean. Now, use the data to summarize the number of goals scored per club in terms of the standard deviation. So what I want to do is look at, let's see, our standard deviation is 15.9. I want to go one deviation above. So this point right here, what would that point be? Well, the deviation is 15.9. So I'm going to draw an arrow right here. This is 49.8 plus one deviation, 15.9. So I'm going to do 49.8 plus one deviation, which is 15.9. So that means this point right here is at 65.7. Now I'm going to go one deviation the other way. So I'm going to take 49.8 and I'm going to subtract off a deviation. And this is 33.9. So in terms of deviations for the goals, they are between 33.9 and 65.7 are one deviation on either side of the mean. Because remember, the standard deviation talks about the relationship of the mean and the deviation. Not the median, but the mean. The mean is our average. I'm not really sure what this one was asking. I was kind of like reading it again. Use the data to summarize the number of goals scored per club. Oh, in terms of standard deviation. Okay, so the mean plus one deviation is 65.7, and the mean minus one deviation is 33.9. This is an easy way to talk about it. That's how the data was spread out. And, okay, so we are at, oh gosh, we're at an hour. Okay, I better stop this video. It's getting kind of long. All right, I'll keep going on the next one.